Well, g'day, it's Charlie, ZL2CTM. Been quite an interesting day actually. So, I've been reconfiguring this radio over the last couple of days because I wanted to basically just make it look nice and neat, have the transmitter down this end nicely, have the IF strip up the middle, audio over here, etc. And just making it look sort of nice and tidy. Also, because I wanted to just play around with it, we're trying out some SBL1s and then just having a dedicated receive IF strip and a dedicated transmit IF strip. And what I found very interesting was once it was built and I started to flash it up, had a whole lot of noise on the receive line, quite similar to the noise we had when we first built this using the ADE-1s. So I tried doing the same thing I did then, and having the small 1K pots sitting on the output of the Si5351, and quite frankly that was, while it worked reasonably well, in fact worked quite well for the ADE-1s, it certainly did not work at all for the SBL-1s, and really degraded the output waveform of the Si5351. So, and what I found, in fact I'll just demonstrate it now. So this whole switch arrangement here I'll talk about in a sec. At the moment in this particular switch configuration, the Si5351 is providing both the VFO for the incoming mixer and also providing the BFO for the product detector. If I just turn the volume up and I just go through the 40 meter band, you can sort of see this interference coming through. Now the antenna is disconnected, and sort of all the way through. There's a birdie there. All sorts of rubbish coming in. So it sort of got me thinking about, square waves versus sine waves. Now I've built, not a huge number, but I've built a few SSB radios and CW radios over the last year or so. And in each case I've been quite happy with the performance from the Si5351. And I haven't really had too many problems to date. The start of the problems that I can remember were in fact that November build using the ADE-1s. And I'm just trying to rack my brains, trying to think, what has changed from those earlier radios. Because I will say, I'm not the only person who's using the Si5351. Pete Giuliano is using it to great success, as well as others. So, I'm not quite sure what's going on. My current batch, the purple Si5351s there, they come from AliExpress. When I look at the board itself, it looks virtually identical to what I would have got through, say, Adafruit. The output waveform seems to be fine. The amplitude seems to be fine. So I don't know if I can say that is the cause, these new boards. So that, interesting. Anyway, so what I want to do in this video here, for interest's sake, and it sort of got me thinking a little bit, is I've got a switch arrangement here which is switching in either the Si5351 providing square waves to the mixer and the product detector, or in the other switch position, switching in my antenna tuner here, which is using an ADE-9850, so it's got a sine wave output, and that's been set up to be a 1.4 volt peak to peak output, so in other words 7 dBm, and the other sine wave output is the VFO up here, again also set for 1.4 volts. So this function generator here is acting as the variable frequency oscillator, and the antenna tune down here is fixed on 9.001350 megahertz on a single frequency spot that I've got, which is one of the modes for the antenna tuner. So that's acting as the beat frequency oscillator. So anyway, so what I wanted to do for a start is I'm going to leave the antenna disconnected, and I'm going to flick the switches across to the yellow position, and the yellow position is the antenna tuner and the variable frequency oscillator coming out of the SIG here. So I turn the volume up, so we are now sitting on like I say, those two sine wave outputs. And just before I go any further, the way the software is set up, the beat frequency oscillator, like I say, is 9001350. So therefore the variable frequency oscillator needs to be the beat frequency oscillator frequency minus our frequency of oscillation. So for example, for a 7.1 megahertz signal, I would need to tune my SIG gen up there to the BFO minus our desired frequency to 1901350. And that's what we see up there. So better zoom up a little bit. That frequency there is essentially our variable frequency oscillator, which will then provide an IF of 9 megs. So, like I say, that is now sitting on both sine waves for both the BFO and the VFO. And as we tune through there, now the clicking is just coming through the output from the digitizer here. I wouldn't worry too much about that. But other than the clicking, much better in terms of noise. Now I'll just flick off the waveform. It's now back to square wave. I'll go back to frequency, and you can hear quite a difference here. So now again, that's the same. Again, the antenna is disconnected, so this is all coming from internal to the radio. And again, go back to sine wave, back to frequency, and it's cleaned up again. Like I say, ignore the clicking from the rotary encoder. Anyway, so that's interesting. So what I'm going to do now, I was going to leave it on 1.9350, which is the equivalent of 7.1 megs, and I'm going to arc up the small radio down here, which is just acting as a SIG gen, and we're just playing a podcast into it. So we'll key it up. So then that's just dumping into a dummy load there. And that's what we're now coming out of there. Okay. So I got the fans coming on from the power supply, so I'll just wait that finishes and turns off. So at the moment that's on, we'll call it sine waves, and then going back to, and now we're back to our square waves. And this is 7.1. So I should got that right. So it should be on orange, orange, and orange. That's right. Okay, let me just put the antenna back on again. Okay, so that's better. So that there is currently the square wave coming out from the Si5351. Flicking back to, and that's now the sine wave. What I find interesting, the reception quality would appear to be better with the sine wave, and I certainly noticed with an on-air signal that I could hardly hear the signal using square waves, but when I flicked over to sine waves, he was much clearer. So this is sort of here as well. That's on square waves. That's back to the sine waves, as we can see up here on the scope. So that's our BFO, and then that's our VFO. VFO and the VFO. Going back to square waves. So we can see there, so this is our beat frequency oscillator. So the amplitude is pretty the same, so that's the square wave, and just listen to the audio quality. So that's really interesting. a lot sort of hashier and certainly not as nice.
You know, and when modems started going,
and if we go back to the VFO,
or maybe 12, but you know, not 56K, but yeah, they somehow did.
So that's the sine wave, obviously.
So, okay, this picture demonstrates
square wave.
What happened on one of 3 of Epic Games' first when they installed the meltdown mitigation. And this is
so that was the VFO swapping backwards and forwards, and again the sound quality just from just on the face of it sounded clearer with the sine waves. So go back to all square waves. It's all square waves.
Diurnal cycle of
all sine waves. So that sort of got me thinking quite a bit, because like I say, let me just unkey that transmitter so we don't overheat that. That sort of got me thinking, because like I say, I've built several radios in the last year or so, and I really haven't noticed this problem. It's been pretty good. In fact, people have asked, and my advice had been, if you go to Solder Smoke, the blog, about a year and a half ago, there was a lecture that was put up on that website that talked about square waves, and the takeaway was square waves are our friend, and in fact square waves work very well and are ideal for mixers such as the SPL1. So I was quite happy since then to pass on that advice, saying, well, I've had no problems with it. Here goes some advice here. I suggest you give it a go. But I have to say, in the last 2 builds, i.e. the build we did in November, and then this reconfigured radio, essentially exactly the same internal, same amplifiers, just a couple extra ones because of the dedicated transmit and receive IF strips. Same problem that started with the ADE-1s. That sort of a lot of birdies, a lot of noise, and just not really ideal. And like I said at the start of this video, reducing the amplitude of the VFO and reducing the amplitude of the BFO into the two, the mixers and the product detectors, or product detector and the balanced modulator, but you know what I'm talking about, certainly made the situation better. But of course on receive, once you started to reduce the amplitude below that 7 dBm, the whole sensitivity of the radio dropped off, to be expected. So I don't believe that is a good solution. So I'm sort of sitting here scratching my head and wondering where to go next. The purist in me is thinking that, well, there's a few things going through my mind. A, do I have an impedance problem? I don't think I have. I put a lot of thought into trying to calculate the input impedances to the amplifiers and the output impedance for the matching, so hence all the transformers around the place. So I don't believe it's that, but I'm happy to be corrected if other people have experienced the same problem and gone, it's an impedance issue. And the other thing that's going through my mind is, I'm wondering, do I need to consider actually filtering the output of the Si5351? Should I put it through a simple filter, pass the fundamental, and then essentially turn it back into a, as we can see up on the screen there, it's not perfect obviously, but turn it back into a sine wave for the radio. So that's the other part. That's the other thing that's sort of going through my mind. Would that be a good idea or not? So anyway, I think that's all I wanted to cover today. So it's been frustrating but also sort of educational at the same time. Switching backwards and forwards was certainly interesting. The sensitivity radio was certainly better. The audio quality was certainly better when running on sine waves as opposed to square waves. So I'm probably going to leave it there. Really happy to hear anybody else's experiences with regards to their home builds, their radio builds, using sine waves versus square waves. like I say, up until November last year, I haven't had really any major problems with using the square wave out of the Si5351. But since that November build, things have changed. I don't know if it's the board, like I say, the Si5351 board, or something else in my approach. Well, in fact, another thing too, I was just on thinking about it. A couple of builds back, I was looking at a diplexer. So a diplexer coming out of the mixer, the first mixer there, just to make sure that it was properly terminated in terms of presenting a 50 ohm load to the mixer for all the frequencies other than the intermediate frequency. I'm just wondering if that's something I should look at. I don't think that's going to be the panacea, but that is something which I want to do. Because the other thing too of making the radio the way it is with this reasonably large copper board here for the IF strip is to make this a test bed. So IF amplifiers, for example, can be swapped in, swapped out for experimenting. So I wanted a sort of a generic radio to do that. Right, okay, I think I've rambled on long enough. Like I say, happy to take any feedback, any ideas. Otherwise, I'm just going to sort of quietly think about what to do next. But an interesting conundrum. Okay, 73 is all, and we'll talk to you soon. Okay, this is a an add-on. There's a station that's running at the moment. There he is there. So I just want to do some comparisons with the sine wave versus the square wave. Sorry about that fan, it keeps turning on and off, it's a bit of a pain actually. I might turn that radio off there. Right, so what I'm going to do, I'm just going to go back to square waves on both the VFO and the VFO. So that's the beat frequency oscillator, and that is our variable frequency oscillator. And we can hear them just coming through. I'm now just going to, on the variable frequency oscillator, quickly change to the sine wave, and we'll hear the difference when he talks. There you go. Now amplitude wise, it's very, very similar. In fact, I'd argue it's the same. So that's the first difference. Now, I'll go back to square wave for the variable frequency oscillator, and we'll just look at the beat frequency oscillator. Currently square wave, same thing. I'll now go to the sine wave when he talks. There you go. Same amplitude, as far as I'm concerned. Well, pretty close anyway. When he comes back. So again, go to the sine wave, and the radio is a lot more sensitive for arguably very, very similar amplitudes in this case the beat frequency oscillator. So right, let's go back to so we're both on square, so square. What I'll do is I will go for a both sine wave. Certainly a lot better. So it would appear that if either or both the VFO or the VFO slash or the BFO, sorry, are sine waves, the radio is much more sensitive. So again, back to square waves on both. Doesn't matter. So I'll do the BFO, the beat frequency oscillator. Much better. Conversely, the variable frequency oscillator, when he talks, much better. And then this is both. Not much difference at all, if anything. So what I'm doing now, I'm now just swapping. So my takeaway there is, if either the variable frequency oscillator or the beat frequency oscillator are sine waves, things are great. If they're both sine waves, there seems to be very little change. So interesting. So like I say in the first part of the video, I'm at sort of a bit of crossroads here what I want to do. Part of me wants to try and work out what's changed between the earlier radio builds and this one, because I've had really no problems with the Si5351 to date. The other part of me wants to build a simple filter, two filters, one for the variable and one for the beat frequency oscillator coming out of the Si5351, and then shove it into the radio. Anyway, I will definitely call it quits here because I've rambled on long enough. Please feel free to make some comments, and yeah, interesting times. Cheers all.